right, hello everybody. Today we want to look at number bases, and on the number basis, we'll be looking at how we can change from a natural base or a decimal base or base 10 to a different base. Okay, and then we look at the flip side, converting from a base to a base 10, and then we look at some few other examples. Okay, so first, we want to look at how, and we are just going to do this through examples. So number one, we want to convert 2, 3, 4. All right, base 10 to a base 4. Okay. Now to do this, you make 4 your dividend. So you draw a straight line, a vertical line, and then you draw that, and then 4 becomes your dividend, your divisor, sorry, 4 becomes your divisor, and 2, 3, 4. Okay. So 2, 3, 4 becomes your dividend. So how many times or how many 4s are there? Let's say how many groups of 4 are there in 234? And there are 58 groups of 4, okay, in 234. And that should give you 2, 3, 2, and that leaves a remainder of what? 2. Okay. Again, you ask yourself, how many groups of 4 are there in 58? There are 14 groups of 4 in 58, and that leaves a remainder of 2. Okay, you go further. And how many groups of 4 are there in 14? We have 3. Okay, that leaves a remainder of 2. And now to end it all, when you get to this point, when your dividend is less than your divisor, 4 divides 3, you say that is not possible. So you write 0, and this dividend now becomes your remainder. Okay, and at this point, you can end the division, and this becomes your answer, but the answer goes in this order. So 2, 3, 4 base 10 will be equal to 3, 2, 2, 2 base 4. And you have successfully converted 2, 3, 4 base 10 to a base 4. Okay, let's look at another one. Number 2. We want to change 3, 0, 3 to a base 3. Okay, we do the same thing, right? So our divisor is 3, and we have our dividend as 303. How many times or how many groups of 3 are there in 103, 303? And there are 1, 0, 1, and that leaves a remainder of 0. Okay, 3 can still divide 101. You ask yourself, how many groups of 3 are there in 101? And we have 33, and that leaves a remainder of 2. We still use that. 3 again can divide how many times? 11, and that leaves a remainder of 0. Okay, and how many times can 3 divide 11? 3 times, and that leaves a remainder of what? 2. We do 3. How many times can 3 divide 3 once? And that leaves a remainder of 0. And that is where you stop. So when your dividend becomes smaller than your divisor, then you are approaching the end. Okay, so here you can say that that is a 0, and this dividend now becomes your remainder. Okay, so don't forget this becomes the remainders. We are interested in the remainders, and your answer, you write that in that form. So we have 303 is now equal to 10, okay, 2020, okay, base 3. And that is how you change from a base 10 to another base. Okay, good. Now, let's look at how we can change from a different base to base 10. So we now want to look at how we can change from a different base to a base 10. So now, number one, we want to change 4, 3 to base 10, base 6 to base 10. And base 10 is also called a decimal numeral. Okay, so when you see a decimal numeral, that means base 10. So here, what you do is to do that. So you have 4, 3, 2. Base 6, and this is how you do it. Now you take the first digit, multiply by the base, plus the second, multiply by the base, and then you keep going. The last, which is 2, and multiply by the base of 6. Okay. When you've done that, you start and giving the base powers to the bases. By starting from the very end, you give this a 0, that 1, and that second. Is that okay? So this becomes 4 by 36 plus 3 by 6, which is 18. Okay, 3 by 6. Plus, and now 2 times 6 to the 0 gives you 1. Okay, so now we have 144 plus 18 plus 2, and that is equal to 164. Okay, so you conclude that 4, 3 to base 6 is equal to 164 base 10. Okay, so every natural number is in base 10, basically. Is that okay? Sweet. Nice. Now let's take another example and see how we do that. Number 2, we have E29 base 12. Now in number bases, E stands for 11, and when you say T, T stands for 10. Okay, so E stands for 12, T stands for 10. Is that okay? Note that closely. And let's see how we go about this. So we're going to do the same thing. So now we're going to do E, which is 11, multiplied by the base, plus 2 multiplied by the base, plus 9 multiplied by the base. Okay, now we start from here, put 0, 1, and 2. Is that okay? So you have 11 multiplied by 144 plus 2 times 12 gives you 24, okay? So let me do 2 by 12 plus 9 times 12 to the 0 is 1. Okay, so we have 1584 plus, we have 24 plus 9. And when you put all together, you have 1617. Okay, so you conclude that E29 base 12 is 1617 base 10. Okay, and that's as simple as that. Now I have two more problems for us to deal with. And so this is some random problem on number basis, and let's take a look at that. We want to find B in the example we have. So let's see that. So for number 1, under that, we have B2 base 7 is equal to 44, okay, base 10. Our question is to find B. Okay, we're going to, so now this is already in base 10. 44 is already in base 10. So we have to harmonize the left side. So you have to change the left side of this equation to a base 10. So we're going to do B times 7 plus, okay, 2 by 7. And then we do a 0 on top and a 1 over there. Now we maintain 44 because 44 is already in base 10. Okay, so this will give us 7B. 7 to the 1 is 7 times B is 7B plus 7 to the 0 is what? Is 1 times 2. We have that, and we have 44 right there. Okay, so now we can find, we have a linear equation now, so we can find our B. So 7B is equal to what? 42. We divide both sides by 7, and our B is now equal to what? 6. Isn't that beautiful? So really, if you want to plug that back in, your conclusion will be that 6 to 7 is equal to what? 44 base 10. And that is your final answer. Is that okay? Good. So let's look at one more example like this, and that will bring our discussions for today to a close. The second problem under this, and we are still going to find B. We have 5B2 base 12 is equal to 734. So we will change the left side to a base 10 since the right side is already in base 10. Okay, so we do 5 by 12 plus B by 12 plus 2 by 12. Okay, and don't forget 0, 1, and 2. Okay, is equal to 734. Is that okay? Good. So now 12 squared, what is 12 squared? So we have 5 by 12 squared gives us 144 plus, this is a B, okay, times 12. So that eventually will give us 12B plus 2 times 12 to the 0. 12 to the 0 is what? 1. So we have 2 times 1 right here, which is equal to 734. Okay? Good. 5 by 144 144 will give us 720 plus 12b plus 2 is equal to 734. Okay. Now let's add this and that. Okay. So we have 722 plus 12b is equal to 734. Now we can group like terms, right? So 12b will be equal to 734 minus so 734 minus 722. Okay. And that should be 14. So 734 minus 722. That should be 12, okay? All right, and then we divide both sides by 12. Now we have our b being equal to what? 1. Okay, so our conclusion will be that, let me bring the conclusion up here. So if you substitute that, we have 5, 1, 2, base 12 being equal to 734. Okay. And that brings us to the end of our discussions. And please let me know if you have concerns, if you have any questions. Okay. And feel free to reach out. If you have a problem that you want me to deal with, kindly post in the comment section. And I'll be more than happy to help you through. All right. Thank you and have a good day. Bye-bye.